Hello everyone, welcome back to my channel. My name is Shobha. I am studying in Sri Venkateshwara College of Engineering, Department of Information Science and Engineering. Subject Data Structure and Application. Today's topic is Optimal Binary Search Trees. Optimal binary search trees are data structures that enable efficient searching, insertion, and deletion operations. They are widely used in computer science and software engineering to organize and manage data. In this, we will explore the key characteristics of optimal binary search trees, the dynamic programming approach for their construction, the analysis of their time and space complexity, and their real world applications. Defining binary search trees. Structure. A binary search tree (BST) is a hierarchical data structure where each node has a key and at most two child nodes, called the left child and the right child. The left child's key is less than the parent's key, and the right child's key is greater than the parent's key. Searching efficiency. The binary search tree structure allows for efficient searching with an average time complexity of 0 log n for search, insertion, and deletion operation. This makes binary search trees a popular choice for sorting, sorting and managing large data sets. Characteristics of optimal binary search trees. Balanced structure. An optimal binary search tree has a perfectly balanced structure where the height of the tree is minimized. This ensures the most efficient search, insertion, and deletion operation. Weighted node. Each node in an optimal binary search tree has a height associated with it, reflecting the probability or frequency of accessing that node. This height information is used to construct the tree in the most efficient way. Minimize total cost. The goal in constructing an optimal binary search tree is to minimize the total cost of all searches, which is the sum of the weighted path length from the root to each node. Dynamic programming approach. Optimal subset structures. The problems for constructing an optimal binary search tree can be solved using a dynamic programming approach which explores the optimal substructure of the problem. This means that the optimal solution for the overall problem can be derived from the optimal solution of its subproblems. Recursive formulation. The dynamic programming algorithm of optimal binary search tree construction involves a recursive formulation where the cost of an optimal binary search tree for a given set of nodes is defined in terms of the cost of optimal binary search trees for its subsets. Constructing optimal binary search trees. Step 1. Define subproblems. The first step is to define the subproblems that need to be solved, which in this case are the optimal binary search trees, all the possible subset of the given set of nodes. Step 2. Compute optimal cost. The algorithm then computes the optimal cost for each subproblems using a recurrence relation that considers the possible root node and the cost of the left and right subtrees. Step 3. Construct the tree. Finally, The algorithm constructs the optimal binary search tree by selecting the root node and recursively constructing the left and right subtrees based on the computed optimal cost. Analyze time and space complexity. Time complexity. The time complexity of constructing an optimal binary search using dynamic programming is 0 n to the power of 3, where n is the number of nodes in the tree. This is because the algorithm need to compute the optimal cost for all possible subsets of nodes, which takes 0 n to the power of 2 times, and the constructor the tree which takes 0 n times. Space complexity. The space complexity of the dynamic programming approach is 0 n to the power of 2, as the algorithm need to store the optimal cost for all possible subsets of nodes in a 2D tables. Applications of optimal binary search trees. Database indexing. Optimal sta- Optimal binary search trees are widely used in database management systems to index and efficient search large dataset. The balanced structure and logarithm such time take them a popular choice for indexing database tables. Compiler design. Optimal binary search trees are used in compile to implement symbol tables, which stores information about the variable, function, and the other entities in a program. The efficient search and the retrieve capability of optimal binary search trees are crucial for compiler performance. Decision making algorithm. Optimal binary search trees can be used in decision making algorithms such as those used in accept system or recommendation engines to efficient search and retrieve relevant information from large knowledge bases. Conclusion and key takeaways. Optimal binary search trees. Optimal binary search trees are highly efficient data structures that enable fast search, insertion, and deletion operations. They are widely used in various applications for database management to compile design and decision-making algorithms. Dynamic program approach. The construction of optimal binary search tree can be solved using a dynamic programming approach which explores the optimal substructure of the problem to compute the optimal cost and build a tree efficiently. Time and space complexity. The time complexity of constructing an optimal binary search tree using dynamic programming is 0 n to the power of 3, and the space complexity is 0 n to the power of 2, making it computationally intensive but effective solution for managing large data sets. Thank you.